Let's do some math. Let's do some really basic math. Yeah, that's the start of this thing that I'm going to do. That's what it's going to be. And hey, I'm Eric. I'm making a game. It's called The God Killer. And I'm here to bring you on this journey with me making this game. This is a top-down 3D puzzler game. It has an interesting property where you can wait as long as you like to make your move, but yet it's got a feeling of action to it. You do fight things. You do knock people across the room. They knock you across the room. So it's an action puzzler? No, I don't know. I always had this problem with my other games coming up with the right genre term for it. Anyways, I'll give you a quick demo of it, and then I will move on to a continuation of the problem I got halfway through on last night's session. Yeah, it's a little bit of a math problem. So, the schedule. Monday through Thursday, 6 to 8 p.m.-ish, Pacific Standard Time, live coding sessions. This thing right here, that's what it is. I always kick off each one with a demo, and then I get into the work. And Sunday, 3 p.m., Pacific Standard Time, some other game development task which is not programming. Related to the game, not programming. And this Sunday, I know for a fact that I'm going to be recording voiceovers. It's actually one of my talents to make funny voices and record them. I ran a voiceover studio for a little bit of time. I've directed actors, I've done recordings. I wasn't the most talented voice actor, but there was one game that I contributed a character voice to that people liked enough to ask me to do it again. And fans of the game, this other game, not God Killer, it's called Drod, have sent me a collection of lines. I'll be recording those lines in like a ridiculous character voice on Sunday, 3 p.m. And then I'll move on to, I think, since I'll have the microphone fired up, recording at least some placeholder lines for God Killer as well. So that's what's going on. So let me go to the demo part of this thing. I have like a few things set up here. Let me go to the game itself. And I don't think I'm going to start it up this time. I think I'm just going to show directly what I've been working on. So I have already figured out how to programmatically create these curves between 2 points. I don't know if this is going to work because I had a whole bunch of new code and I didn't get it all the way working. So I'm not going to try to make it work right now. Right now Unity's doing a build. Good chance it either fails or gives me something which no longer works. And that seems to be what it did. Can I select it? Okay. Oh, maybe not. Maybe it might work. It might work. Okay, it's still working. It's still working. Okay. So I already had this code which will take any 2 points and draw what's called a catenary curve between them. So it actually makes a little mesh. I say it, I mean the code that I wrote makes a mesh around this curve that looks like a cable. And there's things that I can control in it, like how smooth it is, or basically how many segments are used in the creation of it. Right here it's like showing that maybe I didn't make it quite smooth enough. I could just add more segments to the mesh if I want to. What is this? Segment radius, segment. Oh yeah, okay. Segment length. So if I go shorter segment length, it gets smoother. And it's a little dance there between having less polys, better performance, and more polys, more smoothness. It turns out, from the normal viewpoint of the game, I don't need too many polys or smoothness. Okay, so that was the thing that's in the dump pile. The new thing I wanted to do was add sub-curves to these cables. So it'd be like there's another cable that's hanging off the first cable. I think it's an interesting detail. And I got some distance into writing the code that would automatically add these subcurves. These first ones here, I put in more or less manually, just to see what the effect would look like, and to get some idea of how I wanted to write the effect. It just feels like wrong not to hit the play button and walk around the level a little bit. So I guess I will do that after all. Just a short little stint, particularly to show off what the curves look like in the actual game. Right now we're looking at it from a side view. This is not a side view game. It's all top down, all the time. All top down, all the time. And it's almost a tragedy because there's some cool stuff to be seen from other views. But for the integrity of the gameplay, it must be top down. Definitely designed with that constraint in mind. And also for the integrity of the gameplay, the camera view, which you'll see shortly, needs to be a fair distance out from the player. It's going to zoom out a little bit here. Okay, so the player you control is in the middle of the screen. That's the red-haired lady there. Her name is M. She's really tiny on the screen. Again, that's by design. That's what the game needs. The game needs to show lots of detail. It needs to show you lots of information. These cables aren't an actual game element that affects your play. They're just a thing that looks cool. Just a little aesthetic detail. So, on to the cable math. And I think I did the hard part already, which is the calculation of this curve here, which, if you're interested, is a catenary function with a little bit of shearing, a little bit of interpolation that I added to it to make the y endpoints be at different heights from each other, or to allow for the two endpoints to be at different heights. So normal catenary function would be more like a curve that's just has two endpoints that are at equal height, and I made it so it can also shear a little bit, so one endpoint can be down lower than the other. Okay, so in the code I left notes for myself. I was dissatisfied with my understanding of something. Okay. So this idea that I'm going to split up the curve into subcurves, and this is the controlling logic for that generation. And I also decided, for the sake of good showmanship, that I would draw out my thoughts this time. So I've got a little touchpad connected up, and I've got an ability to draw what I'm thinking. It may be a little bit touchy. Oh, that's a little bit weird. Okay, so here is the main curve. I don't know how well this is going to work. I need to divvy it up for subcurves. Now, an easy way to do it, and I made it harder than this for myself, is say, okay, you're going to have your subcurve count. Boy, it is tricky to write with this. If you say, okay, you're going to have 4 subcurves, so they go like that, evenly spaced apart. That wouldn't be hard to do at all. But the thing that I did that made it harder is I said, this is not a woman with 4 boobs, by the way. This is a cable hung here with subcurves underneath. Or if you want, it can be a woman with 4 boobs. It can be both. It can be both. I don't want to make you unhappy. Okay, so the thing that made it harder is I also gave a setting, so I thought this would look cool, to say how what the size of each subcurve would be, and I wanted to express it as a percentage of the total distance. So if I said %25, these four curves would just all begin and end right where the previous one left off. They go, here's curve 1, and then that's got an endpoint here, and then curve 2 continues, has an endpoint that starts here. It's a shared endpoint, I guess, with the next curve. Curve 3, curve 4. But if I say it's percent 30, then it's more like it looks less like a four-boobed lady, which is really irrelevant, but I decided to point that out. And okay, the thing that we get is overlap, and so I wanted to calculate the overlap, or not calculate the overlap, but calculate these points. These are the points I need to know. And I can make this problem simpler. I can make it quite a bit simpler if I take out the curve part, because the curve, I understand how to do the curve. I understand how to do that. So it's just a line, and it's going to have this number of divisions, and each one is going to be this ratio of the entire line. I may give up on drawing out all my thoughts in here in a moment, just because it's like writing with not even crayons. Crayons are easier. Yeah. Okay. But anyways, the same problem. I want to know where the endpoints are for each thing. Now it's maybe a little harder to see how they could correspond. Let's see, that goes there, that goes there, that goes there. Now that just looks terrible. That communicates nothing except that I'm not good at drawing with this particular setup. Okay. So that was fun, but I'm going to go back to my comfy little text bit here, and I'll do the rest with ASCII art. So suppose sub SC count equals 1, SC size equals 1. I'm just thinking of some test cases here. I'll say 100%. And let me make some kind of notation. Let's say this is 1 and 1. Meaning those are the endpoints of the first subcurve. SC count equals 2. So this is at 0%, and this is at 100%. If I said 100%, which is actually, it's valid with if I have more than one subcurve that each one has a different slack height to the curve, it would actually make a effect that's of interest. Okay. There's another way I can represent this. I can just go, I can say each line is one subcurve. Okay, so then I'll try the other kind of trivial cases. 50%. That would be something like that. Something like that. And this would be at 50%. Okay, sharing a single endpoint between the two. All right, what if I said 3? So now I have to think a little bit. But I think it's not that hard. It's more like 2, 3. And then this is going to be 25%. This is going to be 75%. Oh, I have wonderful, wonderful ASCII art. Okay, and one other case I want to just think about is, what if the percentage size is smaller? If I said SC size equals 10%. What is that middle one? That one would be, should be right in the middle. So that would be 45%, 55%, and at the end it should be 90 to 100. Okay. So I could do something that I think is not quite correct, but it's easier to figure out and it would look fine. I could say that I'll calculate the median point, or not the, is it the median? Anyways, the middle point of each subcurve along this 0 to 100% value. And then I'll subtract half of its size to find like a tentative set of endpoints. And then if I find that those endpoints go off the edge, then I adjust so that they're within the edge. So in this case, I would start out with number 2, and I'd say, okay, I think that should be at the 50% mark. And if I subtract half of its height, it'll be at 45 and 55. Okay. This one I would have said I'm at. Is that even right? See, so it's the thing. It's like I feel like I know more than I actually do, or that I've thought out. So how do I get those middle points too? So 100% divided by 2. Yeah, that's it. Because it's basically SC count minus 1. Because if you have 3 subcurves, Oh, wait a minute. What is this first thing I'm calculating? It is the distance between each curve endpoint, but okay, I have it off by one error here. So if I have 3 curves, okay, and that's 1, 2, 3. Okay, I'm gonna stop talking so much until I figure out more shit out. I sound like such an idiot. That's what streaming does to me. It's like, okay, yeah, it's just, what, no, but the other thing, So I'll just shut up just for a moment. That need to portray confidence in everything you say, it's a disease, man. So if I take the count, this is how many curves I want there to be. It's not how many endpoints I want there to be. Let's call this distance between middle point of each subcurve equals 100% divided by SC count minus 1. So that would give us, for each subcurve, that would give us, anyways, okay, so distance is going to be, in this case, 50%. And it's maybe like a little bit confusing to always be saying percent. So it implies some other thing is happening in this calculation, but it could just be units. What I mean to do at some point is scale this distance percent over the total distance traveled to arrive at an actual endpoint. Okay, so I still want to end up calculating the percents to start with. So for each subcurve I, start with middle point, calculate middle point of the subcurve, if middle point less than let's see, if middle point minus half size is less than 0, then middle point equals half size. So that would make me scoot the middle point over a little bit so it fits inside. For anyone that just joined, I'm doing some math calculations for drawing some curves. Okay. Happy to explain more if anyone's interested. So is greater than 100, then middle point equals 100% minus half size. So that's not bad. I'm pretty sure that works with the other ones too. Let me test out a different one. So if I take this one here, the distance between my middle point is going to be 100% divided by, it's going to be the same. It's going to be, no, what? Let me check. So no, it doesn't work for this one. So we get 50% again. No, it does work. It does work. It does work. It does work. So that means that it will try to calculate a middle point here for this one. The bad side of this algorithm is it's supposed to make a little adjustment to evenly space these out. So let's say, actually this becomes more apparent if I've got not 3 but 4. If I say it's going to be 4, not 3, 4, then I've got to do something like it's starting to get a little bit tough now. It's something kind of like this. I mean, that's what I want it to look like. I think that's kind of what I want it to look like, but I think what it will actually do is it'll skew a little bit towards shorter ends, like this. I'm exaggerating here, but I think that's what it will actually do. So my math is not quite right, but I'm willing to just try this algorithm to start out. And it might be a good starting point for making a refinement after that. Sometimes it's like it's hard to get it exactly right, or I should say it's inefficient to get it exactly right on the first try. So I'd have to really prove a lot of stuff with a lot of text like this. And if I just got the code up and going, then that's going to be faster. Alright, so let me delete most of this stuff. And I'll even make it simpler on myself to begin with. I will make it like a little bit of stub code. Again, this is all for the sake of iterative development, where you don't try to do every single damn thing at once, but just kind of test a little bit at a time. Okay, so what I can do is add a subcurve that just does something. So okay, list subcurve. No, just make it one star. Okay, subcurves, add new subcurve. And what did I say it was? Oh, No, this should be. No, I got this in the wrong spot. That's okay. I'll just move it up. So let's take this. No, that's wrong. Okay, I gotta get my functions organized a little bit better, so at least I've got some contracts defined on them. So let me see. So I'm starting out. Call this calc my subcurve vertices. It's going to get passed in the main curve, number of subcurves I want in it, the size of each one expressed as a percentage of the total curve, random chance percentage of it being included versus not included, some random factors for changing its slackness. Okay, so call that. That's kind of the top level there. It's going to return subcurves. And subcurves are just vertices defining the center points that go through the subcurve. Okay. So divide and conquer here. Okay. Calc subcurve ideal endpoint percentages. And that will take a subcurve count. And that was the logic I was going over before. It's just all going to be in this function. The size of one subcurve. Anything else? Well, my return variables. So I'll say out int start percent and then end percent. just did like way too much talking, like I'm gonna do this thing. It would be really confusing for someone to listen to it. It's confusing for me to listen to myself sometimes. You think you're confused? Okay. So here's where I can start with just a stub value. I can say start percent equals 0 and percent equals 100. That's it. Just return for now. Just make sure that some other things work before I start fiddling with that. Alright. So now I've got this other code here. Oh, I know what else I need. Okay, so if I've got that, can I move on to this one? Let's see, what does it actually want? Oh, yeah. It wants the things that I have. Oh, I'm almost there. Well, I shouldn't say that. But I'm almost there for like having the basic algorithm of this thought out. Okay, so that's the main curve segments. Occurs to me, instead of defining like a special type here, which isn't really serving me that well, I can just return some out params. Go out, vector 3, start vertex. Okay. Why don't I just call this endpoints? It just seems needlessly wordy. Okay, and I'll cheat again here. just to get some stuff going. I'll just give it the beginning and ending vertices. Look, I'm close to having something that I can run. It's bad luck to say that, but okay. So here, I want to add a new set of segment vertices for the subcurve. No. Wait, what'd I do? Just almost. That seemed less screwed up. Okay. So clearly I'm missing something. Let's take that out for now. Subcurve. Syntax always messes with me. Jesus, so much stuff for you to complain about here. Okay. Let's see. Float slack height is going to be randomized. Equals decor random. Next. Slack height max minus slack height min. No, that's not how you do it. You go like this. Min. Max. It's still not how you do it. It's just weird enough I feel like encapsulating it. So that function needs an int, but I want a little more precision, which is why I multiplied it by 1,000. And now to get it back to a regular floaty thing, I'll divide it by 1,000. That should do it. That should do it. That should do it. Okay. All. Okay, so then I'll need to correct the call to this to pass segment length. Okay. That's it. It's gonna. I should add some comments here. Although function names aren't bad. Function names are lengthy enough that it might get the idea across. Okay. Figure out. Okay. Skip subcurves randomly. Figure out, ideally, where the endpoints would be. Figure out where the closest existing endpoints, no, existing vertices on the main curve are figure out which vertices on the main curve are closest to the ideal locations. Calculate the subcurve between those vertices. calculate segment vertices going through middle cables for main curve and any subcurves. The subcurve count is 0, then no subcurves. Calculate the mesh to be created that represents a cable aligned with the segment vertices. Also apply decorative adjustments. I need to stop using the word decorative too much though. Also apply cosmetic adjustments, because here in this project it means something specific. Add the mesh to the game object. Hey, Norman! How's it going, man? Oh man, I tell you, it's you'd think when I got home from work I'd be tired of doing stuff on computers, but this is like a completely different thing than work. Actually, just get to write code, which is pretty nice. I don't have to plan anything or worry about politics or anything like that. So this is actually a pretty nice, relaxing time in the evening. That's right. This is the meeting right here, you and me. It's the only meeting. I was just about ready to see if a whole bunch of code that I just put in is going to work or not. So you'll get to bear witness. Chances are it will not. Let me at least try to build it. I'm like so certain it's gonna like crash the first time. I almost just want to run it to the debugger the first time, but I think I'll take a leap of faith and see what it does. So it's code that makes these curves here on cables. I'm gonna delete the ones that aren't actually created by the algorithm, so they don't confuse me. Alright. So it'd be really weird if it worked the very first time. But I will see. I will see. Okay, so I can drag the endpoints here. Let me try it with the case of 0 subcurves in it first. Okay, it's still working with that. So then if I just add in one subcurve. Oh no! It worked the first time! I can't believe it! It worked the first time. Man. Okay. So let me set the random stuff here. So yeah, I'm trying to make like little loops or curves that come down off the bottom of the main curve. I want them to be generated programmatically. All right. So I wrote okay, now I gotta add other stuff. So I want to be able to say the number of subcurves that will be shown underneath. Right now it's only showing one. I want to do more than that. Maybe set that to 50. Going to take a bunch of vertices in an array, and calculate the total distance between all of them. If I traveled from one to the next, how far would I travel? Probably a built-in Unity function, so I don't have to do the three-dimensional Pythagorean theorem thing. Let me just check for that first. My aim is not to be extra clever. My aim is to get things done. Unity calculate distance between 2 points. This has got to be it. Yep. Length plus equal. Okay. That gives me my total distance there. So then I'm going to kind of do the same thing again. If length is greater than starting percent, alright, I'll set these to some defaults just in case the logic I have below doesn't work out. It's not the length that I want to compare against. It's float traveled percent. What was that? Traveled. Okay. I don't need this. would make all that stuff. Before that'll even work, I have to... Okay, I already got some stub values here. I can try those out. So I can see if I can make a subcurve that goes not all the way across the main curve, but over just 0% to 50% mark. And then I can come back and fill this in after I'm sure I can at least create a subcurve over a portion of the main curve. So build all that. Then I wait for the Unity build. And it could be magical again. It could automatically draw that subcurve with going halfway across instead of all the way across, or something worse. But I don't want to bet on that. Did it build? Did it even build? Oh, there's the build. It takes forever, man. It takes forever. Alright, it's too much to ask it to work on the first try. Too much. Too much, too much, too much. But I do have my subcurve count at 1, so that would be one reason for it not to work. Set it to 2. Well, I did make 2 of them. It didn't... Yeah, okay. Time to go into the debugger. Oh, I've already got the debugger running. Okay. Let me try it. Okay. Okay, so that's the ideal endpoint. Start at 0 and at 50%. Oh, I know. Okay, I know at least one bug in this. I'll go ahead and walk through in case I can see another bug while I'm going through it. So did the total main curve distance do something right? Let me see. Oh, nice. That looks about correct. At least it's a reasonable value. Those, I think, are fine. I think what is wrong is my travel percent is going to be expressed as a number between 0 and 1, whereas the values I'm passing in are numbers between 0 and 100, like integer percents. So let me just look for other errors while I'm already here. Travel percent is never going to get to curve start percent. It's going to go all the way through, and these initial default values will be supplied. Oh, wait a minute. Oh, okay. What I said is not true because the curve start percent is at 0, so I can still get to it even with the scale of this being wrong. But the end curve I will not arrive at. Okay, everything else looks like it's going right. So I'm going to just let it run. Let's do times 100. I suppose I don't need all of those parentheses. That would be the same thing. Okay. Okay, that might fix it. That might fix it. It's got a good chance. I give it a 47% chance of making it to the mid mark. Oh. But, huh. I mean, it did something interesting, but it's not right. I mean, I should be kind of grateful that I've gotten so far along without worse problems than this. Huh. Yeah, I'm not sure. I'm not sure why it picked that particular offset. So it would help to know which of these is the start point and which is the end point. So this guy here. Okay, start vertex. Is that the one moving? Let me look at it. Yeah. Okay. So this is the start side, and the left side is the end side. And it's picking a midpoint. Oh, you know what? I forgot. It goes way up here too. So that probably is a good midpoint. Let me just move all this shit closer together so it's not. So, oh, yeah. So this is not bad. Could have set this up a little bit better so I could see it more easily. Here. Let's pull it off into the sky so I can see it better. It did actually get a 50% endpoint. Now there is some weirdness where I'm missing the last segment. It's probably kind of an off by one error. I'll make the segment smaller so it looks prettier. On the other hand, that's actually hiding an error, so let me put that back to Okay, there's the error that I want to catch. That last, I think it's just missing one segment at the end. I think. Jesus. I just kind of slowly wrote a lot of code. Didn't realize I had so much code here. I'm reluctant to edit this because I feel like that should be working. So a problem I've got is knowing if a point is on the main curve or not. I can make that easier if I just set these more precisely. Okay, 34. Let's set the slack. Height to be 0. So that sets it tight. So that means that any point that is at 34y is on the curve. And this guy here, I can check the endpoint. I can see if it's not 34, then it's not on the curve, and that'll help me troubleshoot. So to do that, I'm gonna check. Let's see. Start here. It's the first place where something could get fucked. Okay, so I know that start percent's going to be 0, end is 50, and when it comes out, I want subcurve start and end to have y of 34. Let's see if that is true. Good for start. Good for end. Okay. So before I dig into that, let me just see the end result. Subcurve end, are you at 34? You are. Okay. It's getting trickier now. Oh wait, I didn't check the right thing. So let's see. Let's look at the subcurves. So it's the actual vertices stored in here that I need to look at. So the first one is on 34, the last one is on 34. Okay. Now we go into the code that creates the cable mesh around those vertices. So this first one is going to generate the cable mesh for the main curve. That's fine. This next one, we'll do the subcurve. Alright, so possibly I can figure out if this screwed up. Let me grab that. So this will calculate all the vertices for points that are out a little bit. They're out a little bit from that center point, which is defined by the segment vertices. So it should move out from the center point by radius, and there'll be like points in a circle around that radius. The ones at the end, they won't be exactly on 34, because they'll be at an angle, but they should be close. They should be, the y should be less than 0.1 meter from 34. So let me see if that's true. Huh. It's like not even close, so it makes me think I'm not looking at the right thing. Or I'm not thinking about it the right way. So this y value here is a full 10 meters below the main curve. And that's not what I saw. I saw that curve at 34. There might be like some world local difference. But a bad thing is if there is a world local conversion, that's going to be even harder for me to troubleshoot this. Because I was depending upon that not to be there. Let me look at that again. Yeah, okay, let's see, go calc cable vertices. And I think these must be local to the game object vertices. That would make sense. Yeah, that would make sense. I wouldn't define a mesh and have it be a bunch of world points. It wouldn't be stored that way. It's a representation of the data that's meant to be easily translated if the parent transform moves, so it must be local. Okay, so if that's true, can I say anything else about these? Can I learn anything else about these? Where am I at? Where the fuck am I at? No, it's these guys. That's what I want. Okay. So, okay, I know one thing. So if this is the first point of the subcurve. That means at 20.7, which is showing correctly. Okay, so the first point was showing correctly. The first point of the subcurve was up there, up against the main. So if that is the right y coordinate for that, then down below should also be 20.7. It's not. It's 20.1. So that means that this function, calc cable vertices, is coming up short. Okay, so I might as well just have it run through again. Yeah, I don't know where I'm at now. Subcurve. Calc subcurve vertices. Okay. So here, I'll go here, so I don't look in the wrong line of execution. I want it for the subcurve. And after I get to there, I want to create cable mesh. Okay, calc cable vertices. That's the one. That's the one I want to get to. Okay. That's all. So this little guy gets one more segment, I think. Okay, this is when I came into the same function for the main curve. It probably makes the same mistake for the main curve too. I think I've seen that bug. It's less visible at times. Hit play again. Now I'm in here for the subcurve. So let me think about that. Is the ring count the same thing as the number of vertices? Yes, every vertex gets a ring around it. Those are the center points. These segment vertices are the center points of the cable, and each one gets a ring of other vertices around it. So then I accept the premise that the cable vertices array should have vectors, this many vectors. You multiply the ring count by however many vertices we want per ring. It's 4. The ring count is 27. I also know that the segment vertices are correct because it's starting at 34 here, ending at 34 here. I want to see inside of the loop below some logic which takes this last vertex at index 26 and makes a ring of vertices around it. I've got ring I0 to ring I 27 is the count, 26 will be the last index. So it really should it really should evaluate that last one. Let me see what it actually does. It could be that it does calculate that last one, but the offsets it applies to the, I'll just draw something real quick. So segment vertices, they have the center line that goes down the middle. And these are the vertices. They're in the center of the cable. And this function is going to say for each of these points, let's draw a ring around it. It'll make like a circular ring, except that I've got it defined really coarsely. It has 4 points around it, so it'll draw 1, 2, 3, 4, and then that will end up becoming what's used for polygons to be created around it. It'll do the same for each of these. And my thought is that it's either skipping the last one over here, so that the cable that gets rendered is just going from here to the second to last point, or that the offsets it generates for these points along the exterior of the cable are wrong, like they're pointing down one segment length or something like that. So that's what I'm looking at in the debugger. Okay, so one thing I can do is I can just wait until I get to the very last ring, which will be ring I-26, and see what happens there. And I think I can do that with that, and put this down here just in case it falls through for some reason, which would be interesting in and of itself. So then I'll set the locals down here so I can kind of see what's going on more easily. Okay, ring high, we're at 5, 6, okay, let's get to 26, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, don't want to go past it, 25, 26. Am I there? Okay, it got to 26. So my theory about it skipping 26 because of some logic in here is that's to be discarded. Ring rotation. Okay. Current radius. Oh. This could be it. That could be it. So if I say adjusted, okay. I add like a little bit of code. Adjust radius hard. True. Okay, this is going to be it right here. This has got to be it. So I said if we've got this adjust radius hard, make the ring center equal to the previous ring center. Let's see if that's true right now. Ring center 34, 33.4. Wait a minute. Oh, I haven't gotten down to that yet. Okay. So that's it. That's it right there. I can modify that logic a little bit, but let me just verify. No? Oh, I was so certain. I was so certain. I thought, oh man, I just thought I was right on the verge. of solving this, and that's not even where it executed. Okay. To make matters worse, my ring center is right. Okay. So I'm using the same offsets I had from the last ring because the radius has not changed. Okay. So what are the offsets? Particularly Y. Huh? Oh, it must be like, yeah, it's just got really small values that aren't expressed in the summary view up here. So 0.0116, okay. Okay, so I guess let's go in. Let's take a look. See what these vertices actually become. It's at 34. That's at 34. That's one vertex at 34. It's like it's running out of places to screw up. Maybe it's this inverse transform, but man, it shouldn't be. So this converts it from a world point to a local point. It could be messed up when I rotate around the pivot. Let's see. Nope, it's still good. Maybe the conversion to local coordinates messes it up. What is cable vertex I now? 104. Okay, so I want to go to 104. $20.7. What's the top? 20.7. 20.7. How's it going to be screwed up? It looks like it's going to work, but at some point it gets screwed up. At some point it gets screwed up. $34. And these ones, they're all going to be the same, I think. So let me just walk through those. It's just a couple more points to add. Okay, so now I'm at ring I 26. I should exit the loop. Okay, so let me look at my cable vertices again. They should end at 20.7. They do. They end at 20.7, so what's up? I thought I checked this before. Wait a minute, what just happened there? No, that's fine. Okay. So it's going to assign the value, and I'm going to double check it again, because now I'm running out of things to go wrong. Now I'm doubting my previous conclusion. I thought for sure that when I looked at cable vertices on a previous execution, that the end point did not match the start point for the Y value. Now I'm doubting, maybe I just glanced over it too quickly. Because right now it looks like it's gonna go and do it right. Okay. Well, I can get back to the same point I'm at again real quickly. I just want to hit play and see if it actually draws that correctly. Oh, wait a minute. There is like another one of these that's calculating. What is this? No, I think I might just be in one of those update loops where an event keeps firing that makes this get called again. Okay. So is it going to be screwed up? Yeah, it's still screwed up. This is kind of tricky. I want to get that to work though. Because otherwise I'm just going to be either seeing those gaps or I'll be fiddling with it to get it to the little cheat spot with the parameters where it doesn't show the gap. And that will annoy the crap out of me. Okay. So here's the thing we'll try, because I noticed like it's calling this a whole bunch of times, and maybe on one call it had one result, on a different call it had a different one, and maybe that's what got me confused. So let me see. Create cable mesh, was that the place? Okay, yeah. So let me I'll set the breakpoint there again. I think that's the only breakpoint I've got set here. Oops, I should just clear a bunch of these. Okay. There. Okay, so here, this is for the main curve. It should be y at the start at 34. Oh, 20.7. Yeah, local. 20.7 at the end. Okay, that's fine. And then hit play. I get my first subcurve. And let me double check that that's where it's coming from. Is this the subcurve? Yes. Okay. So 20.7 at the top, 20.7 at the bottom. Nope. Okay, there. There it messed up. Okay, I have got another theory. It's based on troubles I had with floating point numbers before. The theory is that sometimes these two numbers, even though they are equal, because of the fucking weirdness of floating point and IEEE, I think 794, that this comparison is too precise. That there'll be two radiuses that are equal, but not by floating point standards. And epsilon is supposed to be like the smallest number it can reasonably track or something like that. Debug assert. Just do debug log. Now, did I friggin' crash? Oh no, I'm paused. Okay. Let me play with that. Oh, I want to friggin' beat this by 8 o'clock. Alright. Waiting for the Unity build to start. Wait. Come on, go. Go Unity. Go Unity. You can start anytime you want. Anytime you want. There you go. Could have done it 20 seconds ago, but now it's fine. Okay, clear this guy. Okay, radii not equal, all over the place. But I don't think it like consistently says they're not equal. I don't think it consistently says that. Or maybe it does. Oh, I do have a radius type here of ribbed. Oh, that's also why it looks so pronounced. Okay, never mind. Let me set this to plain. Okay, I was wrong about the floating point weirdness. But there is something about the interaction of this radius adjustment. I'm pretty sure that I know what to fix. I'll put that back to rib 3. Rib 2 was the one where it showed up. Okay. So this was a bug I had before the subcurves. I saw it earlier. I didn't fix it then. I will fix it now. I will fix it. Sometimes you just gotta fix it. Come on, where are you at? There's too much code here now. Getting lost in my own code. Right, cable mesh, was that it? No, it's up here. Okay. So this code is sometimes being executed. I have this little cheat here for the decoration, or if I say that we want the changes to the radius to look kind of hard and not smoothed out, that we pull a ring forward. Or really, let's see. The ring center equals the previous ring center. Okay. What I want to do instead, something like this, but not exactly like this. If ring I greater than, if ring I equals the last one, ring I, ring count minus 1, radius changed. I want to calculate the ring offsets differently. I'll calculate them at the current location with the previous radius, or the current endpoint. The previous radius, else if ring I greater than 0. I can do that kind of cheap trick I do that usually works. So this is the one case where my cheap trick doesn't work, and replace that logic with a different approach, which I think is safer. It will at least keep the last endpoint from being set to be the previous one, the previous ring. Okay, I've got a good feeling about this. Waiting for the Unity bill. You'd think it would have a build button to press, or it would just start quicker, but nope. Nope, nope, nope. There it goes. Bug fixed. Okay, now, with just 9 minutes on the clock, I'm going to see if I can get this other one to draw. No, not just that. To calculate the locations that I want based on a more diverse set of attributes that could be put into the inspector. So let me see. Did I write a nice to-do comment here? Nope, I did not. Dummy. As my code gets more complex and loose ends all are in different places, I should just add to-dos. So now I'll just scan through for, yeah, a bunch of green. Okay, so float. Middle point. Let's call it subcurve interval equals 1 divided by subcurve count minus 1. Let me say subcurve middle point equals subcurve interval times subcurve I. Then we say, let's calc the half size. Float half size equals subcurve 2 if subcurve middle point minus half size is out of bounds, and give it an inbounds location. Or I could just, instead of doing that, I could just skip to returning start percent 0 1% equals subcurve size. Okay. Else, if we're out of bounds on the far end, otherwise, not out of bounds. So we say start percent equals middle point minus the half size, and end point, or end percent, is on the other side of the middle point. What are you complaining about? Okay, that's fine. Let's do that. Alright, so that should do it. That should do it. Now it's gonna get crazy. What do I think it'll do? Kind of hard to say, because I've only got one subcurve defined. And I'm saying the size of it's 25%. I think it'll make one subcurve starting from here that goes 25% of the way across and ends here. Let's try it. No, there's a divide by 0 error. What line? 283. Well, that makes sense. So, if the subcurve count is 1, I think I might as well just special case that and be done with it. If subcurve count equals 1, well, basically I'll define the behavior to be exactly what I described. Start percent equals 0. End percent equals math I min of 100 or subcurve size. Return. So there. Waiting for the build, waiting for the build, waiting for the build. There it goes, a little bit faster. Oh, perfecto. 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 Okay. So then, if I want them to not look so junky like that, I can take off the ribbed. Yeah. Let me just get some more subcurbs in there. Okay. Nah, something's up. Something's up. So the special casing works fine, but the general code does not. So let's see. So if I say that there's going to be 2 curves and each one is going to be 25%. I expect the interval to be 50%. Is that true? No, way off. 2 minus 1. Okay. Oh, this minus 1 thing is wrong. So I was thinking in terms of, let me not jump to conclusions. So if I have 2 subcurves, yeah, I expect the interval between them to be, okay, let me see. So that's really obvious when what the interval should be there. Okay. So that's true. 0% here, 100% there. The middle points are here and here, and they are 50% apart. But this logic is not right. That logic is not right. I'm sorry, Norman. I'm not done. I'm going into overtime here. It means I gotta send my partner a text. Ask her what time she's coming home because I say, hey, beautiful. When you coming home? Because that affects when I really gotta stop doing this and make some dinner. Playing this because I just know the algorithm's wrong. Hit stop. 9:30ish. Oh, I got time. Have I been to PAX? Oh, I've been outside of it. It just looks so crowded inside. Like it just looks like wall to wall BO, and like you can't move around without like scrunching up against everyone. I'm not especially afraid of crowds or anything like that, but it just seems unpleasant. Have you been? Okay, so let me see. 0 to 50. So the basic thing. What do you think of it? Basic thing is to get the middle points. Once I have the middle points, I'm pretty set. So let's keep this, meaning the distance between each subcurve middle point. Four days. 4 days there? Oh man, that's signing up. Did you are you into like I know you're into VO stuff, but are you a fan of like any VO artists? Okay, no point. Oh yeah, Mark Hamill's great. I don't know Steve Bloom. I mean, don't know personally any of them, but of course, but I don't know his work. Okay, subcurve interval. I just call it interval. It's just getting ridiculously long. Oh, okay. I'm like not an anime guy. That's probably why I'm not recognizing that. Okay, so that 0 would take me to 25%. That seems more likely to work. You know the guy that is really funny to me is I think it's D. Bradley Baker on American Dad. He does Steve. It's just like such a ridiculous voice. And then like there's like some numbers. He does like some musical stuff too, where he like is like a boy band type guy. Really funny. And then like if like these yelping noises, like if he screeches or something, they're so funny. All right, let's see. Can I get it to? do it. I get it to do it. Did it build? I don't even know if it built. Okay, I don't think it built. Maybe it did build. That's the thing. Never sure. I did save it, right? Okay. Well, then it should have hit the breakpoint. Oh, I don't have the breakpoint going. Here we go. I'll take off this ribbed thing. Okay, so my interval should be 0.5. Is it? No, it's 0. Okay. So that is just floating point mistakes. But also, I think this should be, okay, 1F divided by that, 100 times John DiMaggio's great. Who's the guy that does Billy West? Billy West. And Futurama, he does like 4 voices that are so distinct from each other. I mean, he does more than 4 voices, but he'll have like Fry talking to the professor, and then he's also Zap Brannigan, and it's just like, what? Such distinction. It's just actually 100F divided by the subcurve count. Oh, okay. What are you doing? Oh, I gotta hit play again. Nope, you didn't build, so that, no, okay. This is the time of the day where I get a little bit tired, and I shouldn't try to do anything too hard, even with programming stuff. It's weird. It's like there's different tanks of fuel to draw from. Come home, I've got like another tank for programming stuff that I didn't deplete during the day, but now it's like getting down to the bottom. Okay, so interval should be 50. Good. Subcurve middle point. Expect it to be, let's see, this is for subcurve I 0. Yes. Expect this to be 0 plus 25 is 25. Yes. Half size is like 12 point something. Yep. It will be out of bounds. Wait. Minus half size. Oh, that's right. That's right. I have my size set kind of small. Okay. This might actually work. 13, 37. Well, it'll do something interesting at least. Okay. So have in there? So this one did 0 to 25. I gotta go back and see what it's actually returning again. All right. So that should not be 0, right? 13 and 37. So that's good. And then it's going to have to find 2 points. Okay, no, it's returning from this. Okay. It's going to have to find 2 points that actually are closest to those percents. And I thought this was working pretty well, but it might not be. Well, let me just make sure the percents make sense. Okay, 13 and 37. And the next one, I think it will be inbound. I think its start percent should be after 50. Good. I think M percent should be like 70 something, 80 something. Cool. So this function is fine. This function's fine. And it's hard for me to tell if these coming back are good. I'm guessing they're not. This is probably the next place to drill into. So just hit play there. I don't know, did you just start over with a fresh one? Okay, come on. Okay, so that's the same messed up thing there. Okay. So, okay, I can see one thing that is going right. So the end point of both of these subcurves is about where I expected it to be. It's the start point. It's not where I expected it to be. So, let us hit the break point again. It's true. Okay, I'm not in the subcurve. At some point, travel percent should go past the start percent. So the travel percent one. So I'm waiting for this to go past 13. Simple. Come on, Unity build. Okay, another guy that I like, not maybe for voice talent, but for creativity in performance, in like a totally different way of talking. I know it's got to have a ton of ad-libbing in it. It's Justin Roiland, the Rick and Morty guy. I think it's Roiland that does Rick, right? But that thing with, it's like he just starts and stops. Oh, he does Morty too. Okay, yeah. Like it was so cool to hear that for the very first time. It was a complete departure from the actors, kind of doing like that perfect voiceover delivery of the lines, tightly written lines. I just assume that the script doesn't say like, oh Morty, oh yeah, you gotta. I assume like he adds all that shit in, and it just sounds great. Okay, and meanwhile, my curves are happening, right? And I'm gonna make the size go up a little. Let's see what that does. Oh yeah. Oh yeah. Oh yeah. Oh yeah. Oh, it's beautiful. Oh, Norman, you're here to witness it. It's beautiful. It's beautiful math. Alright. And then I can take the main curve and I can add slack to it. And the other two, dip down with it. Oh man, okay, I can add subcurves. I can, man, I'm glad I didn't quit. It's like getting to the top of the mountain just before sunset, you know, like if you stopped, you said, oh, let's go home. You'd miss it. But good time to stop. Norman, I'm gonna end the stream here. I'm gonna start thinking about making dinner. And yeah, 20 minutes overtime. It was worth it, man. Have a good evening. Have a great evening. Stop in the stream. Stop in the stream. Stop in the stream now.